So now let us discuss about the system model. The system model basically comprises of three main components. We have the intelligent drones, we have the control center, and we have the smart sensors. Smart sensors, such as smart cameras for instance, are sensors which are able to distinguish between the normal, and abnormal activity. So the main function is to sense a distress signal and then send the GPS signals of that particular location to the intelligent drones, which in turn receive the GPS signals and fly to the site of the critical situation and sometimes deliver services such as fire extinguishers, and they also send live data back to the control center where they receive live data from the drones and can also sometimes take control of the drone. So the communication system of the proposed Auto-FRD is made of LoRa, which is low power wide range. So the system communication range in urban areas is about 5 kilometers, while in rural areas it's about 30 kilometers. The LoRa also uses free and licensed frequencies, 868 MHz in Europe and 915 MHz in North America and 433 MHz in Asia. Also, we use ESP32 and RMF95 modules. These components are cheap, they are low power, and they are compact in size with no complexities. They are perfect for IoT devices. This is the transmitter. As you can see here, we have our GPS module, and we have our RMF95 and the ESP32. This is a receiver where we have the RFM95, and we're also utilizing the another ESP32. And after receiving the signal, it directly sends to the drone. This is the hardware implementation of both the transmitter and the receiver, and the achieved results. We did some experiments, and we noticed that smart response drone have a speed of almost 32 meters per second, and this means that they can get to a distance of 15 kilometers in less than 47 seconds. Therefore, the response time is much more shorter. As a result, this also saves lives and rescue people. The drone takes off and fly automatically without any intervention by a person to the accident location and start providing valuable live information to the control station. Also, the drones can take action autonomously, where the drone can carry, for instance, fire extinguishables to suppress the fire in a building. All this is achieved with an extremely low cost compared to a conventional use of to decrease response time, like for instance increasing the number of police or increasing the number of fire stations in the city. All those are much more expensive compared to this proposed paradigm. So we took some samples of transmission and reception messages, and these locations are chosen specifically due to, for instance, this location here is chosen because the environment is much more dynamic. As you can see, we have a presence of vehicles here, and this one is chosen because of line of sight, and this one is also chosen, for instance, because we have a lot of obstacles in between the transmitter and the receiver. And we realize that when we have line of sight, for instance, we have a much higher packet delivery rate, and as the distance increases, so does the packet delivery rate. But even for a distance of almost 3,000 meters away, we still have more than 50% of packet delivery using this LoRa system. And we also measure the signal, the strength of the signal, and we can see that it's better if we have a line of sight than when we don't have line of sight. But either way, as the distance increases, the two line of sight and non-line of sight strength, they both converge. Also, we did a model of comparing this model to a real-life situation. This is the Firetruck response time for the city, for instance, for Istanbul in Turkey, where we calculated the average response time of fire trucks to a fire accident around the city. And as you can see here, the proposed system performs much better. This is also another comparison to, for example, the Auto-FRD system with the police response system, and also the use other proposed drone architectures for response time. As you can see here, for instance, the cost of Auto-FRD system is much less compared to the cost, for instance, of using police as a to reduce their response time, and also to use the other drone systems to reduce the response time. The response time as well is for Auto-FRD system is much shorter than all of this, and reliability is high in Auto-FRD because we can rely well on that the drone will be able to fly when there is a distress signal somewhere. The complexity is very low, and the false rate of an alarm is also quite low. Accuracy of information obtained is high because once the drone is there, you'll be able to observe it. It will be able to take video information and picture information, and this information can be very reliable always. The volume of information is also very high because the drone will be able to fly there and get there as soon as possible and get a lot of information. Also, automation is the system is fully automated compared to, for instance, some other drone systems which are mostly semi-automated. So this is the end of this lecture. I hope you've enjoyed it.